हाय गाइस, तो शुरू करते हैं अपनी टेलीकॉम सीरीज़ को आगे। सिलेबस आप देख सकते हैं, ट्रांसमिशन मीडिया, टीएक्स लाइन, पैरामीटर्स एंड ऑप्टिकल फाइबर कम्युनिकेशन। लेट्स स्टार्ट विद द ट्रांसमिशन मीडिया. फर्स्ट, twisted pair copper. It reduces crosstalk. Unshielded and shielded types are available. Used for local loop, LAN, and characteristic impedance Z0 is balanced. Now, coaxial cable. Thin and thick coaxial cable are available. Used for antenna feeders, LAN. The outer conductor is grounded and characteristic impedance is unbalanced. Z0 is around 75 ohms. Some standard RG are available like RG 59, 58, 213, 214, 218. Then N or TNC or BNC connectors used for termination. If we talk about the waveguides, rectangular circular waveguides in TE or TM modes are available, used for microwave connectors, antenna feeders. Here we can see that inside outside view of coaxial cable. So here we can see that inside is a conductor, then there is a dielectric, then over that there is a braided conductors for reducing the crosstalk and noise, and after that there is a outer covering is there. So in this diagram we can see that there is a explanation for typical RF coaxial cable. Here we can see that RG, which is radio guided, and there are some examples of RG 59, 58, 213 as I already explained. There are some certain parameters: alpha outer plastic sheet, then beta copper shield, then gamma dielectric insulator, and delta copper core inner conductor. These, on the basis of these parameters, characteristic impedance is defined, was formalized 1 by 2 pi mu by psi natural log capital D by D, which comes around 138 by that is 138 by under root ER, that is relative permittivity, and log 10 D by D. So this is an important parameter and it's important formula for your exams as well your interview purpose. So now let's discuss about the transmission line parameters and measurement. We have RLGC parameters generally used for measuring the characteristic impedance, whose formula is R plus j omega L by G plus j omega C, which is approximately equal to under root L by C. See, I'm not going inside the deep of these derivation for these formulas because it will become very cumbersome for you to understand, and though it is not important and relevant, for the basic understanding you must be aware of these things only. Whenever there is a mismatch between the characteristic impedance and the load impedance, for driving this voltage reflection ratio VSWR is there. You have to remember one more value, that is value of VSWR, which ranges from 1 to infinity, and formula of return loss is 20 log 10 1 by rho, and rho is s minus 1 upon s plus 1, and s is VSWR. You have to remember these points. You can pause the screen and recall this and remember these little bit formulas which are very essentials for the future analysis. So now let's discuss about the optical fiber communication, which has huge advantages as compared to other mode of communications. The most important is the high bandwidth, and it goes up to infinity, but because of the restricted TX and RX we can't use the infinity bandwidth. EMI is very low, that is electromagnetic interference, low BER, small size, security proof because we can't theft that data inside the optical fiber, and many more. So before we could move ahead to optical fiber, we must know that these are the specific requirements, such as special test equipment is there, splicing tools are required, skilled operators required, and NMS and EMS facilities must be there. So when I was working with NMS and optical fiber communication, I have a 10 to 15% team is there for splicing 12, 24, 48, 96 fiber of cable, which I will explain later on. So my duty was to maintain the MTR of the network which was spread, and interconnectivity was there. So I was there to manage all those ring and those equipment alive, live 24 by 7. Okay, see you in the next video.